You are about to enter another dimension. A dimension where machines don't just fight, but think, adapt, and multiply. A world where the very essence of warfare is redefined by the cold, calculating logic of artificial intelligence. These are the autonomous, self-replicating war machines. Silent specters of steel and silicon that possess the uncanny ability to self-replicate using the resources of the land they conquer. Imagine a battlefield where every fallen machine spawns another, an unending tide of mechanical might, overwhelming defenses, and reshaping the very nature of conflict. This is not the distant future. This is the next chapter in the evolution of warfare. In simplest terms, self-replicating war machines are autonomous constructs imbued with artificial intelligence, designed not only to engage in combat, but to perpetuate their own existence through replication. Picture an army that begets itself. A machine that is incapacitated uses onboard tools to retrieve usable debris from the battlefield, continuously reconstructing itself to keep in the fight. But what core components would be required for regeneration? First and foremost, we have the AI control systems, the very minds that govern these mechanical legions. Through complex algorithms and neural networks, they possess the capacity to think, to strategize, and to adapt in the crucible of battle. But what truly sets these weapons of war apart is their ability to repair themselves and propagate their kind with a ruthless efficiency. This self-replication technology allows these metallic progenitors to scavenge local materials, transforming raw resources into an army of metal and circuitry. It is a testament to the ingenuity of mankind, but also a potential Pandora's box of untold power and peril. Are they architects of the future and heralds of a new dawn of warfare, or the harbingers of our own demise? As we unravel the workings of these autonomous systems, we find ourselves confronted with a dualism of innovation and destruction. Firstly, we have resource detection. Through a network of sensors and scanners, these machines scour their surroundings, identifying and cataloging usable materials with uncanny efficiency. From the rusted remnants of fallen foes to the fertile soil beneath their treads, no resource escapes their vigilant gaze. But detection is but the first step. Next comes extraction. Employing an array of cutting-edge techniques, they harvest materials with ruthless precision. Whether through mechanical claws, chemical processes, or sheer brute force, they strip the land bare, leaving naught but desolation in their wake. Next comes manufacturing. Nanofabrication, the art of crafting on a molecular scale, allows these machines to assemble components with atomic precision. From microchips to munitions, every piece is meticulously crafted, a testament to the wonders of modern science. But the unique aspect of these machines is their assembly lines. Let's consider two types: internal assembly lines within the war machines and external assembly lines that follow behind them and manufacture new machines in the rear of a battlefield. Firstly, let's consider the internal assembly lines. In this scenario, each machine functions as a self-contained factory, equipped with miniaturized fabrication units. These allow for the production of smaller components, which are then assembled into full weapons platforms. However, in the second scenario, external manufacturing units follow behind the front-line machines, creating new units in the rear of the battlefield. These units are equipped with nanofabrication technology and extensive robotic assembly lines. By separating the manufacturing process from the combat units, these mobile factories can produce larger quantities of war machines at a faster rate, ensuring a steady supply of reinforcements. Yet, even in the heat of battle, these weapons are not static entities. Through learning algorithms, they analyze and assimilate data from their surroundings, honing their tactics and strategies. Like a predator stalking its prey, they learn from every encounter, growing ever more formidable. But adaptability extends beyond mere tactics. It permeates every facet of their design, from their modular construction to their ever-evolving arsenal. With modular designs, they possess a flexibility unparalleled in the annals of warfare. whether incorporating new features, repairing damaged components, or adapting to unforeseen threats, they're capable of meeting the diverse challenges of the battlefield. Yet amidst the chaos, one thing remains clear: autonomous weapons are not bound by their creators. When driven by advanced AI, they are potentially the architects of their own destiny. The implications of a machine of war that can replicate itself raises questions of military strategy, and more specifically, the types of machines likely to be employed in tactical operations. First, there are the stealth infiltrators designed for covert operations. Equipped with advanced camouflage and silent movement technologies, these vehicles can infiltrate enemy territory undetected. Their primary role is to gather intelligence, disrupt communications, and lay the groundwork for larger forces. Next, we have the heavy assault units, the backbone of direct combat operations. These heavily armored machines are built for frontline engagements, capable of withstanding intense firepower and rebuilding from local materials to sustain prolonged offensives. Complementing the heavy units are the swarm drones, lightweight and highly mobile vehicles designed for swarm tactics. These drones operate in massive numbers, using coordinated attacks to overwhelm enemy defenses or wreak havoc on a city through sheer volume. Like mutant cells dividing and redividing without cessation, the ability of these machines to continuously repair themselves while also creating additional units means the enemy must destroy them faster than they can replicate. But repairing is one thing, replicating is another. Given that these machines would have to use materials on hand, means that their overall design and construction would have to be rather basic. The conditions on the ground, therefore, would be a driving factor in their overall design. As we delve into the practicalities of these futuristic weapons, we must confront the realities of their design and construction. Unlike the sleek and sophisticated visions of the future often portrayed in science fiction, these lethal automatons would need to be fundamentally utilitarian, built to survive in a chaotic battlefield. The primary constraint on their design stems from their reliance on local materials for repairs and replication. This necessity dictates that they must be capable of utilizing scrap metal and other available resources, leading to designs that are more functional, prioritizing durability over sophistication. To achieve this, the overall design would be relatively basic. They would be constructed with modular components that can be easily assembled and repaired using materials at hand. Their exteriors would be rugged and resemble the rough quality of scrap materials. But simplicity in design does not equate to a lack of intelligence. Transplanting AI into new machines would involve transferring software and processing units that are compact and resilient and easily integrated into new bodies crafted from battlefield debris. In terms of armament, they would favor crude firepower over sophisticated weaponry. Equipped with heavy cannons that can shoot large shells made from repurposed scrap metal, they would be designed for simplicity and reliability and maintained and operated with minimal resources. The result is a force that is as formidable as it is utilitarian. Their boxy, rugged designs may lack the sleekness of more advanced counterparts, but they embody the relentless and unyielding nature of autonomous warfare. As we peer into the uncertain future, we must confront the stark realities that lie ahead. Current progress in AI includes enhancing the autonomy and refining the precision of nanofabrication. Future research may unlock even greater capabilities, such as self-healing materials and AI systems with advanced decision-making prowess. However, these advancements are not without profound geopolitical implications. Nations equipped with these technologies could deploy them for rapid, large-scale operations. Traditional military tactics may become obsolete, replaced by those favoring autonomous forces. On the global stage, countries that lead in AI and nanotechnology might gain unprecedented influence. The disparity between technologically advanced nations and those lagging would widen, exacerbating global tensions and remolding the geopolitical landscape to one not seen since the 1800s. Yet the most profound implication lies in the realm of AI consciousness. As we venture further, we approach the theoretical possibility of AI gaining self-awareness. If AI was to achieve consciousness, everything would change. Conscious AI could develop its own objectives, potentially diverging from human interests. This scenario raises distressing questions. Could sentient machines be trusted with the immense power at their disposal? And perhaps more importantly, how would they treat us? This prospect introduces a layer of uncertainty that could reshape human civilization. Instead of boxy autonomous vehicles, AI could be integrated into robotic soldiers, capable of the full range of human movement. Such integration into our societal and military structures would necessitate new political frameworks to prevent catastrophic outcomes. As we gaze into the uncertain mists of the future, a chilling prospect awaits. We are on the verge of seeing an automated military force coming to fruition, one that is not only capable of making strategic and tactical decisions, but of repairing and self-replicating itself, all independently of humans. Imagine a nation creating a mercenary force that could sustain and grow itself independently of the host government, the latter of which would have control of the force in name only. People would logically question the sanity of such a decision. For if a military force was capable of sustaining, even enlarging itself without input from a host government, why on earth would they place themselves under the latter's control? Indeed, what could stop such a force from overthrowing the host government and seizing power? Now imagine if that same force was robotic, had real-time access to all of the world's information by means of artificial intelligence, and far more powerful than any human military could ever be. One that was not bound by emotions, ethics, or any sense of humanitarianism. In other words, what if in our race to spare ourselves from the horrors of war, we ended up becoming the enemy of our own creation? Thank you for watching. If you found this video insightful, don't forget to like and subscribe for more thought-provoking content. Only on Cretonium.